Good morning, dear students. My name is Ferhan Mazher, and the subject we are studying today is physics. This is CAIE Cambridge O Levels Physics 5054. Today we are going to solve a theory paper. We call it paper 2, and we have selected the latest paper till today. It's May-June 2022, and it's paper 2-1. This paper 2 belongs from the zone 1, and in this video I'm going to try to solve the section A of this paper. The section B of this paper I will try to solve in another video, and soon I will upload that video also. So let's start today's paper. My name is Ferhan Mazher. Okay, so here we go. So we are talking about May-June 2022 2-1 paper. Time allowed is 1 hour 45 minutes, and we are going to attempt the section A. Okay, it says answer all the questions in this section, answer in the space provided. Figure 1.1 shows a model of the human arm. The rubber band represents the muscle that moves part of the arm XY. Okay, so this is the rubber band which shows the muscle which moves this arm XY. A mass is suspended from XY as shown in the figure 1.2. The weight of the section XY is negligible and the model is at rest. Okay, so here you have the pivot, and here the muscle is applying the force, and its moment arm from the pivot is 2 centimeter. The moment arm of the mass is 18 centimeter from the pivot. So you should understand this. Okay. The first question coming up on your screen, which is of, I think, 2 marks. The question is, state 2 ways in which the dimensions of the rubber band changes as the mass is added to the section XY. You can see the length of the rubber band has increased and the thickness of the rubber band has decreased. So it's a 2 marks question. So let me show you my answer. Okay. So length of the rubber band has increased and the thickness has decreased. Okay. So next is state the form of energy stored in the stretched rubber band. So when you stretch a rubber band, elastic potential energy is stored in the rubber band. So elastic potential energy. It's a 1 mark question. Okay, and then it says state the principle of moments. The principle of moments is very simple. If a body is in equilibrium, the sum of the clockwise and the anti-clockwise turning effects or moments is equals to 0. Okay, or in other words, you can say if a body is in equilibrium about the pivot, the clockwise moment and the anti-clockwise moment about the pivot, they are equal to each other. So 2 marks question. Let me show you my written answer. So here we go. It says, for a body in equilibrium about a pivot, clockwise moment is equals to anti-clockwise moment. 2 marks question. Simple and straightforward. Okay, next question is explain why the force that the rubber band exerts on the section XY is larger than the weight of the mass. The reason is very simple. You see, this is trying to produce an anti-clockwise moment about the pivot, and this mass is due to its weight is trying to produce a clockwise moment about the pivot. And because both the moments they are equal to each other, and the moment arm of the rubber band is small, and the moment arm for the weight of this mass is larger, which is 18 centimeter. To have the same moment, the moment is equals to the force multiplied the perpendicular distance between the pivot and the line of action of the force. Because they both have the same moment, and so and the moment arm of the rubber band is smaller, so the force it should provide should be larger than the force provided by the mass or the weight, so that the moment can be same. Moment arm of the force exerted by rubber band is smaller than the moment arm of the weight. So that's why the force exerted by the rubber band has to be larger. Okay, so that was my answer. Okay, so I have already checked them with the marking scheme. You don't need to worry about the marking scheme, but if you have the marking scheme, please. I also have opened the marking scheme here. You can check the marking scheme. Yeah, here we go. The marking scheme is also here with us. Let me increase the size so I can show you. Okay, so this is the marking scheme. Okay, so I will show you at the end of the question. Okay. So then he says, okay, then the question is the mass is suspended from the section XY in the figure 1.2 has a weight of 4 Newton. Calculate the force that a rubber band exerts on the section XY. So very simple. You know, the clockwise moment and anti-clockwise moment, they will be equal. The force exerted by the rubber band is F, and its moment arm is 2 centimeter, and the weight, the force of the mass which is acting downward is its weight, and that is 4 Newton, and the moment arm is 18 centimeter. So F into 2 equals to 4 into 18. So F will be equals to 4 into 18 divided by 2, and that will be 36 newtons. So the force exerted by the rubber band on the section XY is 36 newtons. I hope you understand. Okay, so the next question coming up. Explain how your answer to the B third part is different if the weight of the section XY is not negligible. You see, if the weight of the section is also there, if the weight of this section XY is also there, so it will be acting here and at the center of its gravity. So it will be acting downward. So it will also produce a clockwise turning effect. So the force which the rubber band has to provide to counter this larger clockwise moment should be more. Okay. So if the weight of this XY is also here, it will be acting here somewhere downward. So both of these, this mass and this weight of this rod, they will be producing a clockwise moment. To counter this, the rubber band provides a force which produces an anti-clockwise moment, and that force has to become larger. So let me show you my answer. I have written this. Weight of the rod will produce clockwise moment. To counter it, force exerted by rubber band will be more. So the rubber band will have to provide more force to counter now the increased clockwise moment. So that was the question number 1, and let me show you my question. I am showing you the marking scheme of the question number 1. You can pause the video and you can take your time with this marking scheme. Okay, so we are going to the next question. The next question coming up on your screen is question number 2. He says, figure 2.1 shows a wind turbine. So here we go. We have a circular area, blades, and okay, so this is a wind turbine. He says the wind blows directly towards the turbine with the speed of 12 meters per second. In 1 second, 60,000 kg of air passes through the circular area, swept out by the blades. Calculate the kinetic energy of this mass of air. So, you know, the kinetic energy, the formula for the kinetic energy is 1/2 mv square. So I know the mass that must be in kg that we already have, and we will take the square of the speed of the air. So very simple, I can calculate it. Okay, so kinetic energy is equals to 1/2 mv square. So it will be equals to 1/2 into 60,000 into 12 square. So just enter these values in your calculator. You will get 432,000 joules. 432,000. I think this is not, it's 432. It's more than that, I think. So 432, I think I have made some mistake. I have written here 1. This 1 is not there. Let me check from the marking scheme. Yeah, that 1 is not there. So please make sure that this 1 is not there. This is 430. Okay, so how many zeros? 1, 2, 3, 4. 1, 2, 3, 4, and 5. Okay. This is 4, 3. This is not 1. This one is not here. This is 4, 3, and 0, 0 joules. Okay, to make that correction. So we rounded it off to two significant figures. Okay, so I hope you have made that. By mistake, I wrote 1 before the 4. So just make that correction. A wind turbine releases no carbon dioxide into the atmosphere while generating electricity compared with a coal-fired power station. This is an advantage of using a wind turbine. State one reason why it is important to reduce the amount of carbon dioxide produced. You see, the carbon dioxide is it creates greenhouse effect, which causes global warming. So it's important to reduce the amount of the carbon emission. State one reason, carbon dioxide is a gas which causes greenhouse effect, so reducing it will reduce global warming. Then the question is, suggest one advantage of using a coal-fired power station compared with a wind turbine. With the wind turbine, the problem is that the wind do not remain same throughout the day, throughout a week, throughout a month, and throughout a year. The speed of the wind and the amount of the wind changes with the season. But you know, the coal power station that can be available to you 24/7. So coal power station is more reliable and it's available 24/7, while the wind turbine depends upon the wind conditions, which obviously changes. I suggest one, a coal-fired power station can work throughout the year. Wind changes with season. Okay, that's my answer. A coal power station releases 0.9 kg of carbon dioxide when it generates 1 kilowatt hour of electric energy. Define the kilowatt hour. If a machine who's using a power of 1 kilowatt works for 1 hour, the work done will be 1 kilowatt hour. A machine whose power is 1 kilowatt, if it works for 1 hour, the work done will be 1 kilowatt hour. 1 kilowatt power used for 1 hour, that is known as 1 kilowatt hour. Okay, now next question they are asking you is, he says, calculate the mass of carbon dioxide saved when the wind turbine has a power output of 20,000 kilowatt and operates for 12 hours. Okay, so now the power is given and I can find, and the time is also given. So I can find the energy in kilowatt hours, and then I can tell how much. Okay, so here we go. So energy is equals to power multiplied time. So power is 2000 kilowatt and the time is 12 hours. So the energy will be 24,000 kilowatt hour. In the statement of the question, you know, they have told us that I'm going to use the method of proportion, mass and energy. They said if 0.9 kg carbon dioxide is generated, 1 kilowatt hour energy is produced. So our question is, when 24,000 kilowatt hour energy is produced, how much is the carbon dioxide emitted? Okay, so here I will, this is a ratio, a proportion, proportion method. So I write here the mass will be equals to 0.96 multiplied by 24,000. I hope you all understand this method, the method of proportion. And just multiply this with the, on your calculator, you get 23040 kg. So that's 23,000 kg. 23,000 kg. Okay, it says wind energy is a form of renewable energy. State the name of one other form of renewable energy. Solar energy, geothermal energy, tidal energy. These are the some examples. I have written here only the solar. So this question number 2 is done. So let me show you the marking scheme. So my dear students, here the marking scheme for the question number 2 is showing up. And you can check your answers here. I have already checked my answers. Okay, question number 3 is coming up on your screen. He says, define the latent heat of fusion. The latent heat of fusion means the amount of heat required to convert solid into liquid at its melting point. A very simple, straightforward definition. Amount of heat required to convert solid into liquid at the melting point of the solid. During this temperature remains constant. Okay, then he says, okay, okay, we have to produce it. He says a sample of metal P at 100 degrees centigrade is heated steadily until its temperature reaches 400 degrees centigrade. The melting point of the metal is 250 degrees centigrade. On the figure 3.1, sketch a graph to show how the temperature of the metal changes with the time. So they're talking about heating curve. So that metal initial temperature is 100 degrees centigrade, and you will raise its temperature from 100 to 400 degrees centigrade. The melting point of the metal is 250 degrees centigrade. So when you will raise the temperature from 100 to 400, so when you will reach 250, the metal will melt. So the time duration in which the metal will melt, the temperature will remain constant. And once the whole metal, all the metal has melted, then the temperature will start rising again. So we will draw this. Okay, let me show you. Okay, so here you can see I have drawn that. From 100 to 250, the temperature as the time passes by, on the x-axis you have time. As the time passes by, the temperature rises. When the temperature reaches 250, for some time, the temperature will become constant. The reason is when the solid will be melting, the metal will be converting into its liquid state from solid state. During that, the temperature will not change. And once all the metal has converted into liquid, then the temperature will again start rising and it will go up to 400 degrees centigrade. So your graph should look like something like this. I hope you understand. Okay, then the question is, a sample of a different metal Q has a greater latent heat of fusion than the sample of the P. P and Q are metals with the same melting point and the samples have the same heat capacity. The experiment is repeated with the sample of Q. This sample is supplied with the same amount of energy per second as is supplied to the sample of P. Explain how the graph of temperature against time for the Q differs from the graph in the B first part. You see, because the metal Q, its latent heat is larger, so it will require more amount of energy to convert at its melting point from the solid to liquid. So when the graph for the sample Q will reach 250 degrees centigrade, and that graph will remain on 250 for a longer time because its latent heat is larger. So it will require a larger amount of heat. To get that heat, it has to remain, it will take longer time. So the graph will be, you see this horizontal portion for the sample Q, this horizontal graph, which is at 250 degrees centigrade, and that will be longer. Okay, so look at my answers. I have written the answers. Okay, so Q has higher latent heat of fusion, so it needs more energy to melt as compared to solid P. So the horizontal graph of Q will be longer than horizontal graph of the P. This horizontal graph on the temperature time graph, that will be longer for the Q. I hope you understand. Okay, so let's have a look at the marking scheme. So question number 3's marking scheme is showing up on your screen, and I hope you can pause the video and you can read this marking scheme. Okay, so we are going to the next question. The next question is question number 4. It says two parallel rays of light, one red and one blue, enter a glass prism. On the figure 4.1, sorry, figure 4.1 shows both rays of light before they enter the prism. The blue ray is also shown incident on the different side of the prism after passing through the prism. So they say, okay, we have a red light, we have a blue light, and this is the prism. So they have shown the blue light will bend like this. Okay, what they want. The ray of blue light strikes the left side of the prism at an angle equal to its critical angle. See, on the figure 4.1, mark and label the angle of incidence I and the angle of refraction R for the blue light as it enters the prism. So the angle of incidence is, you see, they have already drawn a normal here when the blue light enters the prism. So this will be angle of incidence and this will be angle of refraction. So let me show you. I have done that. So you can see this is the angle of incidence and this is the angle of refraction. Then they say on the figure 4.1, continue the path of the blue light after it strikes the left side of the prism. So because uh, this angle of incidence here is the critical angle. This angle of incidence here is critical angle. So when the light will come out, it will travel along the surface. The angle of refraction in the rear medium will be 90. So it will travel along the surface. Okay, so I'm back. So the blue light, because it's, you know, here the angle of incidence in the dense medium is equal to the critical angle. So when the light will come into the air, instead of going, its angle of refraction will be of 90 degree. So it will travel along the surface of that prism, along the surface of that prism. Okay. Now, then, okay, then they say on the figure 4.1, continue the path. We are done with that. The refractive index of the glass of the red light is smaller than the refractive index for the blue light. On the figure 4.1, draw the path of the red light as it travels in the prism and after it strikes the left side of the prism. So let me show you. I have done that. Okay. So the red light, it will bend like this. And when from here, it will come out into the air from dense medium, it will bend away from the normal. Here, it will bend towards the normal. Here, it will bend away from the normal. So this is how you will draw for the red light. Okay. So then it says state what is meant by the critical angle. So they want me to find out what is meant by the critical angle. So angle of incidence in the dense medium for which the angle of refraction in the rear medium is of 90 degrees. So that angle of incidence in the dense medium is called critical angle. So it's a simple, straightforward definition. Okay, then their question is that the refractive index of the glass for the blue light is 1.5. Calculate the critical angle C for the blue light in the glass shown you're working. You know, N is equals to 1 divided by sine C, a famous formula for the critical angle and the refractive index. So I can write here N is equals to 1 by sine C and 1.5 is equals to 1 by sine C. So sine C will be 1 divided by 1.5. Sine C will be equals to 0.666. So C will be sine inverse of 0.666. In your calculator, you will enter shift sine bracket start 0.666 bracket close equals to the critical angle will be 41.8 degrees. So when you round it off to two significant figures, it will be 42 degrees. So my final answer will be 42 degrees. So the question number 4 is completed. So let's have a look at the marking scheme. So my dear students, the marking scheme is showing up on your screen. Question number 4. Marking scheme is showing up on your screen. You can pause the video and you can take your time. So the So our answers are right. Okay, so now we are going to the next question. The next question is question number 5 coming up on your screen. He says, okay, so you can see the whole question. Okay, he says the figure 5.1 shows a simple DC motor used in a toy car. So it's a simple DC motor. He says terminal A and B are connected to battery and the motor rotates. Okay. On the figure 5.1, add labels inside the boxes to identify the parts of the motor indicated. Okay. So this A, basically, this is a carbon brush, and this one, its name is split ring commutator. So let me show you. So here we go. You can see that carbon brush and split ring commutator. Okay, so we go to the next part. He says on the figure, okay, B part is state what happens to the rotation of the coil when the number of turns on the coil is increased. You see, when you will increase the number of turns of the coil, the turning effect will increase. So the motor will rotate faster. And rotational speed increases. Okay, that's my answer. The magnetic field between the poles of the magnet is reversed. So when you reverse the magnetic field, the direction of the rotation will also reverse. Okay. So then their question is, okay, here we go. The next question they are asking is, the power supply to the motor is switched on and off at a steady rate. On figure 5.2 shows how the speed of the toy car varies with the time as a result of the power supply being switched on and off. Describe the motion of the toy car. So this is a speed time graph. So it means that the speed is increasing non-uniformly, then the speed becomes constant, then the speed decreases non-uniformly, but it do not become zero. And again, same cycle happens again. The speed increases non-uniformly, then becomes constant, then decreases non-uniformly. It do not reach zero speed, and again the same cycle happens. So this is how you describe the motion of this toy car. It's a 2 marks question. Let me show you my written answer. So a toy car accelerates with the non-uniform acceleration, then it moves with the constant speed, then it decelerates non-uniformly, and then it again accelerates. So this continues periodically. Okay, so that cycle repeats. Okay, so next question they are asking is the voltage supplied to the motor car is switched on for a longer period of time and off for a longer period of time at a steady rate. So just what happens to the motion of the car. Okay, so if the voltage provided to the toy car is keep on for longer time, the time for which the car speed becomes steady, that will become a longer time. For longer time, the car will remain at a steady speed. And when you will keep it off for a longer time, the speed of the car will decrease, and it will decrease more than it has been decreased in the previous part. And it might, if the time is long enough, it might becomes at rest. Okay, so that's the difference. Okay, so top speed will remain for longer time. When speed decreases, it might come down to zero. Okay, so these are my answers. So that is question number 5. So hopefully you understand. So the question number 5, which answers are showing up on your screen, and you can pause the video and you can take your time with this. Okay, so we are going to the next question. The next question is question number 6. He says a light-dependent resistor, LDR, is used to sense the amount of light in a room. Figure 6.1 shows part of the circuit used. The LDR is not shown. Complete the figure 6.1 by drawing the circuit symbol for an LDR between the point P and the Q. So here you have to draw the symbol of the LDR. LDR is basically the light dependent resistor, and you can see this is the symbol for the light dependent resistor. So you have to draw this symbol. Okay, then he says Second part, explain how the voltmeter reading changes as the amount of light falling on the LDR increases. So they are talking about this, how the reading on the voltmeter will change. So here you have the LDR, okay? So when the light on the LDR will increase, the resistance of the LDR will decrease. So due to this, the whole resistance of the circuit will decrease. So due to this, the current coming out of the battery, that will increase. So now in this fixed resistor, its resistance is still the same, but the current flowing through it has increased. And you know the voltage drop is V equals to IR, so the R is still same for this fixed resistor, but the current flowing through it has increased. So the voltage drop across this will increase. So let me show you my written answer. The resistance of the LDR will decrease due to decrease in the equivalent resistance of the circuit. Due to this, the whole circuit's resistance has dropped because LDR's resistance has decreased. So due to decrease in the equivalent resistance of the circuit, larger current will come from the battery. So the voltage drop at the fixed across the fixed resistor at the fixed resistor will increase because V is equals to IR. Its R is still the same, but the current has increased. So the voltage drop across the fixed resistor, that will increase. So the voltmeter reading will increase. Okay, that was a 2 marks question. Now the figure 6.2 shows part of a circuit containing 3 resistors. The current in the 4 ohm resistor is 2.4 ampere. Show that the current in the 5 ohm resistor is 1.9 amperes. Very simple. So these two resistors, they are parallel to each other. So in this resistor, in this upper branch of the parallel circuit, I know the resistance and I know the current, so I can find the voltage drop here. The voltage drop in this resistor will be equal to the voltage drop in this resistor because they are connected parallel to each other. So once you know the voltage drop and we know the resistors here, so I can easily find out the current flowing through it. So let me show you how this is done. So the current flowing through this 4 ohm resistor is 2.4 ampere. So I can find the voltage drop across this 4 ohm resistor. So that is V is equals to IR. So V is equals to 2.4 into 4. The V will be 9.6 volt. So the voltage drop here is 9.6 volt because this is parallel to this. So here the voltage drop will be also 9.6 volt. So now here on this 5 ohm resistor, I know the voltage drop, I know the resistance, so I can find the current. V is equals to IR, so 9.6 into I is 9.6 equals to I into 5. So I will be 9.6 divided by 5. So the I will be 1.9 ampere, 1.9 ampere. So that was what you have to show. Okay, then they say, okay, calculate the potential difference between the point X and Y. So we have to calculate how much is the potential difference here. So the current in this branch is 1.4 ampere. The current in this branch is 1.9 ampere. So current here will be 2.4 ampere plus 1.9 ampere. So if you know the voltage current through 6 ohm resistor, you know the resistance of 6 ohm. So you can find the voltage drop here. So voltage drop on this point and plus the voltage drop on this point, and that will give you the voltage drop between X and Y. So very simple. Let me show you. So the current flowing through the 6 ohm resistor will be 2.4 ampere plus 1.9 ampere, and that will be 4.3 ampere. So once you know the current flowing from here, that is 4.3 ampere, and you know the resistance, I can find the voltage drop here. So that will be V equals to IR. So V is equals to 4.3 into 6, and that will be 25.8 a volt. So I know the voltage drop here is 25. I know the voltage drop here is 25.8, and I know the voltage drop here on parallel combination is 9.6. I will simply add both the voltage drops. So the total voltage drop will be V1 plus V2. That will be 25.8 plus 9.6, and that will be 35.4 volt. And when you round it up to two significant figures, it will be only 35 volts. So this question is done. So let me show you the marking scheme. So my dear students, question number 6 is marking scheme is showing up on your screen, and you can pause the video And you can take your time with this marking scheme. I have already checked my answers with it, and they're good. So by the end of this question number 6, we have reached the end of the section A. And after that, the section B starts. And the section B we will do in my another video. And soon I will upload that video. So my dear students, today in this session, in this video, we have attempted May-June 2022 Physics 505421 paper, and we have done only the section A of this paper. The section B of this paper I'm going to do in another video. If you find this video interesting and useful and you have learned some answers and concepts from here, please share the link of this video onto your Facebook account, onto your Instagram account, and onto your Twitter accounts, because that will help me promote my channel. It's a great blessing for me to be able to teach so many people around the globe through this YouTube channel. It's a blessing. Thank you very much, everyone. Have a good day. God bless you all.